Yeah, thanks for the introduction. Yeah, I'm delighted to be able to present here. So if you see my title, yeah, you expect the answer. Yeah, what is 5G and why do we need it? These are the questions which are asked by my management and so on. What you probably haven't really spotted is a question mark at the end of the title. So that's what I'm trying to figure out. So that's sort of my job. Maybe I have some tiny answers to it, but of course we are all in the process to figure out what 5G is, what it should be, and where we should focus on together. Before jumping into 5G, let's see where we are right now, because 5G is a lot of speculation and the future, but we have at least some data facts which we have today there. So if you look at Vodafone, an operator in 30 markets, this is what we do in terms of our traffic and customer view. So data traffic growth is in Europe about 45% per year, and about 100% in our emerging markets, including India. So you see there is a lot of growth in traffic. About 3/4 of the traffic is video and web browsing, and the other services don't play such a big role. And if you see what customers do today on operator networks, so if you look at video, the majority is very low data rate, 240 points, 360 points, with relatively modest data rates, but this is actually moving up. So we see a shift in video quality, also with new devices and so on. But that's sort of what's happening today. So let's move forward. The 2020 year is mentioned by a lot of people, but actually if you design a generation, it should actually still have some relevance during the whole lifetime of a generation. So if we now design the system for 2020, and then we deploy it and start to deploy it, then it will be outdated already after a few years. So actually, we have sort of to look beyond 2020, 2025, 2030 or so, if we really want to do something revolutionary. Because I think by 2020, LTE is still a pretty good system and will be very, very relevant by 2020. So self-driving cars. I mean, you've all seen all these experiments which all the car manufacturers are doing. And this is in its infancy today, but they all invest a lot of money in this. And maybe by 2030, this is the norm. Maybe this is where really, this is how traffic and transport works. And we have to think of, what would be the relevance of the mobile industry to this? How can we enable things, and how can we help that it's working well? The same with transporting goods around. Yeah, we've all seen what sort of press announcements by Amazon and postal services in different countries. It will definitely change, and I think we need to understand those requirements, and that's not easy, and then help design a system which can support those. If you look at how connectivity will transform our lifestyle and also health, so we have caring for elderly. So if you look at aging population, not only in mature Western countries, but also in emerging markets. So this is a huge topic for society as a whole, where I think the mobile industry can play a big role. Same with health. I think that will be completely revolutionized. I mean, we already see all these things happening now, but they are all on a very small scale right now. Devices at the moment are sort of phones and things and gadgets which I hook on, but they will be woven in and even implanted into people. Yeah, and Sarah was already mentioning robotics and so on, so this will also happen. And that is about people. There will also be things connected, and Sarah was mentioning 500 billion, so that means 50 to 100 per person. So this is actually, if you scale it down to this per person, then you actually see how how relevant this will be. And of course, it's also changing how we as humans interact with our surroundings. Yeah, with smart objects, with other people, and also between us and the internet. So that was 2030, but actually the future is already starting now. So there was something in the news last week. I think some of you may have seen it. Some university in Norway did an experiment where they had a virtual reality screen and were steering a camera which was on a drone, and they could look around with moving the head in the surrounding. So if you analyze this, so what it is you have a high data rate, so a video. You also have a low data rate. It's a remote control of this drone. The content at the moment is very local, but it could also be global because this is not yet connected to, say, a satellite view or something like that. Yeah. At the moment, this is using legacy short-range communications infrastructure, but they don't do yet the steering automatically yet. But that would require low latency. And of course, this is sort of a toy somewhere in the countryside in Norway. Yeah? But if you want to do these kind of things in, say, in a densely populated areas, you need really a bit more reliable communications. And you also need to see where you have the content. So we see a lot of things are emerging right now which could play a role in 5G. They're not yet scalable or not yet mature, but there's incredible speed right now in terms of new services and new opportunities. So why do we need 5G? What are the requirements? So one key thing, and that was, also one of the comments of one of the questions is, we need to enable new services. So just having yet another bit pipe, which is a bit faster and a bit cheaper and a bit lower latency, I think that's not good enough for technology. Is not good enough for the end customer to convince them that they should pay more money. It's not good enough for operators to deploy networks, and I think also not good enough to get new equipment. So how can we help other industries to reinvent themselves, and how can we contribute to this? So one of the things is moving from communications networks, nice to have, to essential control. We also need ultra reliable. So remote surgery was mentioned. So I think at the moment I wouldn't like to be in a remote surgery on a mobile network, but I think sooner or later this will happen, and so we need to understand those requirements properly in order to design the right networks. Also, a lot of things will be localized or centralized. So we see a shift towards the cloud and towards the edge. So if I do traffic steering, so if I use the networks to steer traffic, mobile operators have base station every square kilometer where people are. There is a sort of a compute node with a radio, which could actually be used to locally control things and build up an infrastructure to enable things. And then the tactile internet is a keyword which I will mention later. And of course, Internet of Things or Industry 4.0, that's where we see new requirements for new services. And we need both very low and very high data rate, and we have different latency requirements. It's outdoors, it's indoors, but it's also in vehicles, and actually also in body networks. So that leads to technical requirements. And that's where the most important thing is to enable new services. But we need a very consistent, ubiquitous data rate and capacity. Having a peak rate is kind of nice, but it's irrelevant to 99% to the end customer if it's nothing they can base a service around or rely on it. We may also need ultra-low latency. The 1 millisecond was mentioned. Reliability and resilience, but also the cost coverage is very important for M2M services. At the moment, we have a pyramid where we as an industry address the top 10%. But actually, in order to exploit the whole pyramid, we need to have much lower cost, higher reliability, higher reliable and higher coverage M2M network in order to support much more devices to come to this 500 billion. And of course, energy is very important for us as operators, but also for all the other players here. And energy was always a bit of an afterthought. Yeah, we did LTE, and then after LTE was there, we did a study item in 3GPP to see how we can improve the energy. I think if you do 5G, energy needs to be there from the onset. And for an operator, what is very painful is the time it takes to launch a new service, to make changes. So the network the network architecture isn't flexible enough to come up with the speed we see with devices. So if you see the speed of terminal devices today, how they develop, our networks at the moment are not flexible enough, and that is really very important that this can be automated and can be fast. Okay, but it's also important that 5G is utilizing all available spectrum, not just focus on the new spectrum, but also on the existing spectrum. If 5G is a step change better than 4G, why wouldn't I refarm 4G or 3G at some stage to a 5G band? Yeah, so and our ambition should be really to make it a step change better than today's technologies. Otherwise, it wouldn't be so relevant. But what's important about these requirements is, and here is latency, battery lifetime, and speed. This sort of what Sarah showed, this spider web diagram. I only have 3 dimensions here. We don't need all these requirements at the same time. And that's actually quite important. We need to see where do we want to sit, and it doesn't need to be one system which is meeting the requirements at the one time. Okay, if we look at requirements, I mentioned before, consistency is what matters to the end customer. Yeah? This is an example of a train journey. Yeah? I don't tell you which operator and which train line, but you can see it's very varying the speed, so that's the throughput. The same is, by the way, if you walk around the office, we did experiments. If you look at your instantaneous speed, it's going up and down all the time. Yeah? And we need to map this to a service. We can't tell this customer that it's because of technology and so on. We as an operator need to make sure that they get a consistent service. They don't care about what the underlying technology is. So this is some experiments we did with our partner FTW in Vienna. So we had here a task, photo browsing on a smartphone. We got 50 people in the lab and had a different speed. If I look at this photo browsing, with 1 megabit, I get a mean opinion score of 3. With 7.5, I get 4.5, and with 14, I get a little bit more. So 7.5, you get really most of it for photo browsing. If I now have fluctuations, if my speed goes between 1 megabits per second to 40 megabits per second, and I have the same average of 7.5 megabits per second, actually the mean opinion score will be 3.5. So the peak isn't relevant to the end customer at all. Even the average isn't relevant. It's actually the minimum which is relevant. So this looks like rather like the 1 megabits per second. So it's very important that if we design technology, that we don't just look at measurable, abstract technical KPIs, but really understand what it means to the end customer. I mean, otherwise we have yet another system which, if we as an operator can't sell it for premium or can't differentiate with it, and the end customer doesn't see any difference, I think it's not fulfilling its purpose. So I think in the past it was ignored quite a lot on what it actually means to the end customer, the services. One reason is also that the services are actually changing over time quite quickly. Yeah, photo browsing wasn't a topic 5 years ago, but it's now what people do. So it's important that we keep on the top, and that's where we're working with some of the universities to understand this properly. Another thing which I think was mentioned at the last year's summit here by Gerhard Fettweis from the Vodafone chair, the tactile internet is a topic where if I have extremely low latencies, I can actually mirror some of the human interactions towards the tactile internet. So how I move a mouse on a screen, or and then really the communications networks can play a role here, which they don't at the moment. And we did also some investigations about remote desktop and so on and so forth, and we see that latency is really playing a big role. So the 1 millisecond seems to be the number which is consensus around. So that's needed for some services, but we don't need this for all services. So again, we need this flexibility. I need to see what is the right sort of mode of a 5G network for the right requirements. So if you look at latency, so where are we today? Yeah, we have about 25 to 30 milliseconds we can get with LTE in terms of a user plane latency, but we have all kinds of other latencies in terms of core setup and so on and so forth. So it's really important to understand all those latencies and understand how they would play a role in a customer service. And it's not just the run, but it's the whole run, transport network, core, and the internet, and that needs to be looked up in a joint up view. And if you want to get 1 millisecond, okay, why do I need to go back here? Why can't I write it locally? And there are ways to actually change the latency. One is to look at new waveforms. Then the frame design needs to be looked at. Paging also needs to be faster. The DRX cycles can be changed. I can also cache content at the right place in order to achieve a shorter latency. And I need to have the right place for the control functions in a network, which will be virtualized. Yeah, and that's so there is a toolbox to actually influence latency, and we should exploit it and look at it when we do 5G development. So now let's look a bit on technology and architecture. So, so what are the building blocks for 5G? So the air interface plays a role, but it's, as was said before, it's not just about the air interface, it's about changing the whole system. But for the air interface, we should have a fresh look at coding modulation. There are good examples like GFDM, where you can squeeze more out of your spectrum, or higher order coding modulation. There are some ideas around where we engaging with people on full in-band duplex. So if this would be working, that would be great, because we can sort of in an optimistic sense double the spectral efficiency, but the reality is a bit lower here. Massive MIMO is a big topic talked about, but we need to look what is the practice, because for a deployment it's about weight of an antenna and size of an antenna, and that's where we have to find the right trade-off, but also the right innovation. Because why should an antenna be in panel on a mast which people don't like? Why can't I spread the antenna around and integrate it into the fabric of a building? And interference cancellation is, of course, remains a topic in order to enable very dense heterogeneous networks. Device-to-device is something which is mentioned in the 5G technology building block areas, but we have to see what role it plays, because device-to-device is here today. Yeah? We have Bluetooth, we have Wi-Fi Direct and so on, but they're not really taking off. So we have to see why and what would be actually the customer benefit. On spectrum, we heard about the higher spectrum bands, but actually 5G should also play a role in the lower bands below 1 gigahertz. And it is important that 5G is not just focusing on new spectrum, so new generation equals new spectrum, but looking at the whole spectrum which is available for for operators to deploy more in the coverage bands and more in the capacity bands. So, and it's also important that 5G is not just focusing on yet another license band, but making the best out of the licensed and unlicensed world. The buzzword for today is software-defined architecture. I think that's happening. I think that's already happening before 5G, to be honest. Software-defined networks, that's what we are working, and we have tried this last years. So that's now moving into commercial. But of course, 5G will probably be software-defined from the onset. And what's very important is also autonomous networks, where for us as an operator, the operations of networks is very complicated and it needs to be automated. So if we go to heterogeneous networks with macro cells, outdoor small cells, indoor small cells, and lots of frequency bands. So for LTE we have so terminal manufacturers have to implement 40 or 50 bands. So that shows the complexity of 4G already. So for 5G we need to have a system which can address those things. On the architecture, we can have a fresh look at the architecture and see what's really needed, what's the right thing. And the architecture, by the way, should not be a 5G architecture. It should be an architecture for 2G, 3G, 4G plus 5G networks plus fixed. Yeah, for an operator, we wouldn't like to have a separate architecture for separate technologies. So we need coexistence with low and high bands. I mentioned this. The architecture needs to support this. We need to go to denser networks. Also, we need to support this. RAN will be virtualized. The intelligence will be distributed. And it's not just in the network, it's actually also in the terminal. Yeah, the terminal is part of the network. And carrier aggregation at the moment is, again, for LTE it was sort of an afterthought. For 5G it will be the integrated way to develop it. What can we do? The ideas around is separation of control and data channel. So if you have so many bands, why do we need a control and data channel in each of the bands? Separation of uplink, downlink, I come later to this. Also, where do we have the right control function? And yeah, there's a big debate ongoing everywhere about should everything be distributed or centralized, and it's important that we have really proper metrics and proper view on this and have a proper analysis what's the right thing to do. And the answer, or my answer to this today is it needs to be virtualized, then I can shift it here or there depending on the requirements. So let's have an example of ideas which are around. So the uplink and downlink at the moment is from, if you connect to a base station, you have uplink and downlink from the same base station at the moment. And that's fine. If you have a macro network, that's the right thing to do. But if you now have a heterogeneous network, if I receive the terminal in the downlink is associated to the cell according to the receive power. But the terminal transmits with the same power to all the heterogeneous nodes. And therefore, if I would do the uplink association based on downlink receive power, which I do today, it's not really the right thing to do. So this is an example of, that's a test bed which we have for small cells. And that's some simulation. So that would be the traditional assignment. So the reds is what would be assigned to small cells. So this is all covered with small cells. If I would use a different association, I could actually carry much more traffic on the small cells and be much more efficient. And our simulations show that we can achieve about 100% gain in the uplink. That's some work we do with King's College. Yeah. So we should have a fresh look at this. Yeah, we see it's promising, but it's not yet mature and not yet integrated in any standard and so on. The same with energy reduction. So if you look at the load of the network, it's going up and down. We go to a heterogeneous network with lots of overlapping cells, and we need to be able to switch off things on a longer term, so in hours or at nights, but also in shorter term, so in milliseconds and so on. In the devices we do this today, handsets and terminal, they switch off for very short time and save energy. We need to have the same attitude in the networks, but the design of the system should support this. Yeah, because at the end, we as an operator, we say we want to have an ultra-reliable network, and we want to have an ultra-energy efficient network. So now we need some creativity to get those conflicting requirements aligned. Okay, so let me conclude. So I mentioned a lot of requirements, and every operator has their own requirements and so on, and that's probably not a good idea if we get everybody saying something slightly different and slightly different terminology. So we are working very much within NGMN with other operators to align our views on what's the vision, what are the services which we see, what are the requirements, and also have an early view on some of the technology building blocks and architecture. And of course also to have a common view on spectrum, and it's very important that we work across different regions of the world, also on the spectrum topic. So that's where at least Vodafone is putting a lot of emphasis right now, is on NGMN. And yeah, here I have a lot of questions, probably also for the academic people amongst the audience. I hope that there will be some answers. Yeah, the big questions about revolution or evolution. Yeah, we need both. I mean, if there's no step change to LTE, nobody will bother to put it there. Yeah, we have seen other air interfaces. So WiMAX was, I think, a good technology, but it wasn't really a step change and missed the window of the time window of opportunity, because it wasn't massively better than the existing HSPA networks there. So we have also seen other technologies which didn't really see the commercial daylight, and we need to make sure that 5G is really a step change. Otherwise, I think it will not be commercially successful. It's important to really understand the services, but I mentioned at the beginning, and Sarah had similar statements about the other industries. We really need to engage with the other industries, automotive, healthcare, logistics, and so on, to really see how we need to design the networks in order to support them properly. And the technology components, some of them sound quite nice, but we really need to quantify the benefits properly in order to understand how they could support the 5G. And it needs to be a scalable system with lots of requirements and so on. And the scalability is a challenge here because it should still be simple to operate and to deploy. Yeah. Okay, good. So to summarize, so what is 5G? Yeah, it's a step change in performance compared to what we have today in licensed and unlicensed. It's complementary to LTE and Wi-Fi and the evolution, so there will be some elements which will be complementary. Some of them will replace it. It needs to allow the same customer experience on fixed and mobile. It also combines, from an operator point of view, the existing assets, spectrum and deployment assets, and enables new ones. What's also very important is that it should be a manageable IPR regime. So that's, if this doesn't happen, nobody can build devices. And if you want to have 500 billion devices, and each device has an IPR tag of $10, I think this will not work. And of course, it will be scalable, virtualized. We see virtualizing already today, and will be software based. And why do we need it? Yeah, we want to enable new services. We need a more consistent data rate for the new devices which come along, for the new capabilities. And we also need to have a lower cost and lower energy consumption. Okay. So thanks for your attention.